Hi friends, I'm Matt Jeffs, the Global Ergonomist here for TuMeke Ergonomics Education. Welcome to this video on the Liberty Mutual Snook Tables. The Snook Tables are 20 different ergonomic tools used to assess manual material handling. They take into account factors like load weight, lifting frequency, carrying distances, and much more. By understanding the Liberty Mutual Snook Tables, you can make informed decisions about enhancing workplace safety. The Snook Tables were developed at Liberty Mutual and published in the journal Ergonomics back in 1991. It's important to point out here we're using their published tables. Nowadays, there's a newer automated equation assessment from Liberty Mutual. We'll cover that in more detail in a future video. But the Snook Tables were made to estimate the portion of workers who can safely perform manual tasks. The aim was to reduce low back injuries and strain and sprain injuries. Liberty Mutual suggests manual tasks should be designed for 75% female workforce success. That means 3/4 of working women can perform a task without injury. This is a valuable goal because it ensures 90% of the male workforce will find the task safe too. Taken together, this means most workers can perform a task safely and successfully. So think of it as population measurements. The Liberty Mutual Snook Tables measure the portion of people who can perform a task without overexertion. The 75th percentile of females is a crucial boundary. With Snook Tables, lower population numbers mean more people are at risk, so our aim is to keep our population number high. This keeps our injury numbers low. Now in prep, the first thing we do is interview and observe workers to understand their job demands and their tasks. Then we focus on the most strenuous manual handling tasks to get our numbers. In our example, the lifting task we're examining is ending between knuckle and shoulder height. That's 28 inches to 53 inches from the ground, according to the Snook Tables. Remember, we're aiming for a task that 75% of female workforce can do safely. So our first step is to find the correct table. In this case, it's going to be table 2F. That's the female population percentages for lifting tasks ending between knuckle and shoulder height. Again, that's 28 to 53 inches from the ground. Our second step is to find our weight. We use a scale or a force gauge and we get out into the field, and the field measurement of the boxes in our example is a load of 18 pounds. Now we go find the row on that table for our weight, and in the Snook table we cannot find one that's 18 pounds, but we do find the next higher increment, which is 20 pounds. Whenever our field measurement is lower than our nearest table estimate, it acts as a safety feature, ensuring we stay within safe limits. Next, step 3, we look for hand distance. We always carry our tape measure with us out in the field, and we look for things like reaches and lifts and that sort of thing. In this case, the field measurement for our horizontal reach is only about an elbow reach, about 10 inches. We find the column for the hand distance on our Snook table that will locate that position and hold that as well, and move on to step 4. We want to find the frequency now. We always carry a camera into the field for photos and for videos, and sometimes we bring a timer and a tally counter to measure the frequency of our lifting tasks. Our field measurement in this example is 1 lift every 5 minutes. We then find that column for the lift frequency on our Snook table. Moving along to step 5, now we look for hand height. We take that tape measure that we carry around and we look for where our load begins and where our load ends in the lift cycle. This example starts with a vertical height of 40 inches from the ground and our ending vertical height of 45 inches from the ground, meaning our vertical hand travel distance is only 5 inches. We find the row on our hand height on our Snook table, and as before, we use the next higher increment if we can't find 5 inches. In this case, 10 inches is our closest increment, and this is what we'll use the most. Again, whenever our field estimates are less than our row or column or table estimates, this is actually a safety feature. Next, we come to scoring. We cross where our columns and rows intersect and overlap with one another to find our safe population estimate. Where our 10-inch hand distance column and our 5-minute frequency columns intersect and overlap with our 20-pound weight estimate and our 10-inch lift distance rows lies the population figure we're looking for. Where they cross, we arrive at the safe female population percentage of 89%. This means 89% of females in the workforce can perform this task safely. We move on to step 7. We're not done yet. This is coupling. Coupling refers to the point of contact between the manual handler and the load they're handling. NIOSH rates coupling on a scale of good, fair, and poor. NIOSH states that coupling between the handler and the load with no handles or no cutouts yields a grade of fair. Now, due to this NIOSH score, Snook Tables recommends we subtract 15% from the safe female population score we just arrived at, which brings us to our conclusion, step 8. When we subtract our 15% NIOSH hand coupling score from our initial female population for lifting score of 89%, the score is adjusted downward and the female population for lifting score is now 74%. Since tasks should be designed for 75% of the female workforce or above, this is as close as we can get. And remember, this means that over 90% of the male workforce can do this task safely too. This means our example is an acceptable risk for lifting according to the Snook Table recommendations. Now, how do we interpret this? With Snook Tables, higher percentages mean more people can do the task safely, right? If our numbers came in well below the acceptable risk, instead of 74% much lower, we'd explore ergonomic solutions to bring that risk under control and recalculate. We might explore administrative controls to see if the palletized loads came in smaller or lighter boxes. We could explore engineering controls to see if the loads might stay palletized or on a conveyor through our supply chain. The 75th percentile for females limit is crucial. Below this limit, everyone is at higher risk for back injuries. Above this limit, almost everyone is protected. These numbers help test ergonomic choices to find sensible solutions for everyone. They also widen the employment pool to find more people who can do these jobs safely. Now, for demonstration purposes, our example here was admittedly a simple one. The Liberty Mutual Snook Tables can be used for more complex tasks, but that's really outside the scope of this video. As I mentioned at the outset, there is an updated version of Liberty Mutual assessments. Through automation, Liberty Mutual equations save us from having to sift through all of those tables to find the right ones. Stay tuned for an upcoming video where we feature the Liberty Mutual equations. Until then, if you find using Snook Tables or Liberty Mutual equations a bit cumbersome or clunky for most daily use, we've got you covered. TuMeke Ergonomics provides point-and-click video solutions using your phone. AI solutions make using Snook Tables or the Liberty Mutual equations faster, easier, and simpler than ever before. So feel free to reach out to learn more. Until next time, this is your global ergonomist, Matt Jeffs, for TuMeke Ergonomics Education, reminding you to use AI to work smarter, not harder. See you next time, everybody. Bye-bye.